Good morning, everyone, and welcome to our March 2026 ecologic Innovation Showcase. So it's actually our first one for the year, so thank you for coming in bright and early. I'll give it a couple of minutes for people to barrel through the virtual front doors before we get a start. I'm really excited about today's event because I do think all our events, we have great presenters, but we do have really three very different, very unique, and very innovative opportunities here that are coming out. Although that based in Victoria, I know there's a lot of you that are dialing in from all over the country. So I'd really encourage you to reach out because I think these organizations here have very large footprints and can service nationally. So we'd love to see these innovations and circular economy opportunities adopted in all corners of our continent. So uh, I'll just give it a second for people to dial in, but round of introductions. So my name's Doy Lee. I'm the industry manager with ecologiQ. Along with me for today's event and my co-presenter, I'll introduce Lily Rose Palmer, our senior industry advisor.
Hey everyone, nice to see you. Very excited for the session today.
Hmm. And just to let you know also that today's session will be recorded and uploaded to our ecologiQ YouTube after the event, and we'll also be sending out a copy of today's presentations to all of you who registered for the event, because the aim of the game is to encourage you as a call to action. It is Global Recycling Day. This year's theme we are talking about, being recycling heroes, and I think that if you want to be a recycling hero, it's not just about being here and seeing these organizations, but actually putting into practice some of the innovative practices that are in place as well. So next slide, please, Lily Rose. I'd like to acknowledge that although we're dialing in virtually, that we still meet on traditional lands. So for me, I'm dialing to you from Melbourne, Victoria, on the lands of the Eastern Bunurong people of the Kulin Nations. I'd like to acknowledge elders past, present, and emerging, and any Aboriginal or First Nations people here with us today. Here in Melbourne, it's yarring season or wombat season. And I think all of us are probably here because we probably do have some affinity with that environment and probably an interest in all things sustainability and circular economy. Now, these are concepts that we talk about in terms of our business. But I think for me, it's amazing when you look back at traditional owners and First Nations that they just called it caring for country, and they were able to do so for thousands and thousands of years. And we've come along today. We're calling it a circular economy, but in many ways, we are working back to the future and working aspirationally to something that they were able to do, which is live really in such great balance with their environment. And I think it's just a great starting point when we do these acknowledgements. And I think all of our presenters here today will probably talk in some way or another to that sentiment and that objective. So next, please, Lily Rose. For those of you who haven't heard of ecologiQ before, because I know that I think we've seen a few new faces in the audience here today. ecologiQ is actually a Victorian Government initiative that started off probably about 5 years ago to really purposely look at using recycled materials as a priority and divert that from landfill. So we know that's just the starting point to the circular economy, but here in Victoria there has been and there continues to be a transport infrastructure boom, and there was recognition that we should really look at that to optimize that demand for materials and see if we can catalyze and kickstart and jumpstart the use of recycled materials as a priority and make it business as usual as part of that step change towards a circular economy. If you hop to the next slide, Rose, we can talk to you that so here in Victoria, there's a policy that's been in place, the Recycle First policy, and really the crux of that policy is it talks about optimizing. So if you've been a transport project contractor here in Victoria, chances are you've come across the Recycle First policy. There's actually been 69 projects to date, and it talks about optimizing the use of those materials. And the word optimize is very purposeful. We're not here to say maximize or have hard targets. It needs to make sense from a safety, the balance of cost, and proximity and carbon and all those other elements, which I'm sure all of you appreciate as well, and to use that wherever we can. And secondly, report on the volumes of those materials used. If you jump to the next slide, I'm happy to report that since the policy's been in place in start of 2020, we've now reached over 7 million tonnes of recycled and reused materials here on our Victorian transport infrastructure projects. Or if you're here in Melbourne, it's enough to fill over 2.5 MCGs for anyone who follows the cricket and footy. So next slide. Now, we can't do this alone. So there's many partnerships that are in place to help make this happen. I'd like to introduce a couple of our panelists here today who've come along to help our presenters and really help our audience sort of, scaffold these organizations and assist them to onto the journey towards success. So in no particular order, I might actually start off with Leanne Griffin here, National Circular Economy Lead with Arab, and actually one-time founder of the ecologiQ program. Leanne.
Thanks, Doi. Yeah, hi everyone. Yeah, so as Doi said, I'm Leanne. I'm the circular economy lead at Arup and a former team member of ecologiQ. So very familiar with the program and all the great work that you do, and really looking forward to hearing about the initiatives today. Thanks.
Thanks, Leanne. And I'd like to introduce Nicholas Lee, who's a Manager of Materials Assurance at the Victorian Department of Transport and Planning, to offer the client perspective and asset ownership. Nicholas.
Thank you, and good morning, everyone. So Nicholas Lee, Manager Materials Assurance. I look after the team that manages and operates the various material registration and accreditation schemes that support the delivery of DTP assets. So yeah, thanks for having me, and really looking forward to hearing the presenters today.
Fantastic. Nicholas, thank you. So without further delay, before I bring our first presenter here from SAMIBitumen, just let the audience know you can ask any questions of our presenters here today in the Q&A function on Zoom. So just please make sure you address it to the presenter, because I'll get them to jump in after they've done presenting and answer your questions. So we'll have 3 presentations today, and I'll kick off now and hand the virtual mic over to Hamid from SAMIBitumen to take it away. Hamid, over to you.
Well, I'm going to jump in first. So I'm Brad Richards. I'm the state manager for the southern region of SAMIBitumen Technologies. I'm just going to give you a brief introduction, and then we'll pass over to Hamid. So yeah, welcome everyone. Thanks for joining us today. Jump on to the next slide. So SAMI is Australia's largest importer or supplier of bitumen into the country. And we supply products all around the country. No matter what state you're in, we can supply and deliver anywhere in the country. Next one. So we have 50,000 tonnes of bitumen storage capability. And sorry, I'm just going to whip through all these slides because they're going to be available later on to flick through anyway. But so we have lots of capability to supply anything that you need. Next one. As well as supplying the bitumen, we can also test it. And we've got a brand new testing facility in Sydney that we've used to develop a lot of our products with. So, and they're all NADA accredited testing that we do. Next one. Okay, I'll pass you over to Hamid.
Thank you very much. Thanks, Brad. Hello, everyone. My name is Hamid. Thank you for joining us, and thanks ecologiQ for providing this time to present our product and this recent development. So we are now talking about the biomaterial and the biomaterial that we are using as a binder that we are using in the pavement construction as a bio binder to reduce the carbon footprint, improve the circular economy, and help our environment. So what are the biomaterials? Actually, biomaterials that we are using is mainly referred to the renewable materials that they are coming from the living organism. There are several different types of biomaterials like the lignocellulosic biomass, animal waste and fats, agricultural residue, algae-derived oils, and industrial bio-waste. And the examples around us are wood, straw, food, paper, pulp. All of these, actually, they are coming from the initial bio. Next slide, please. And there are some classification and the categories for the bio binders. So the first one is the different base source. It depends on the biomass type. So we have different type of biomass, lignin type, tall oil top, bio oil, vegetable oil that we can use in the bio binder. The other category is the function-based category, the role in the binder that we can have as a modifier, as an extender, and as a replacement. So normally the modifier, they tune or enhance the bitumen, The extenders are stretch the bitumen, so we can add more, like 10 to 30%. And replacement is when we are fully replace the biobinder with the bitumen, so it's more than 75% actually. And the other category is the processing base. So the production method of these biomass and biomaterials are different. So sometimes we use pyrolysis, sometimes we use esterification, fermentation, and so on. So these are the categories. Next slide, please. One important thing is that, so in a general understanding, maybe is a wrong assumption that everything when we say bio is very safe and is very healthy. But we need to be careful that some poisons actually are biomaterials, like ricin, like nicotine, like so a lot of the biomaterials are toxic, and we need to be careful that bio is not meaning that it's non-toxic, and we have to take care about the safety data sheet, and we ask for the safety data sheet of all the producer and check the health and safety requirement of the material that we are using. Next slide. And why we are using biobinders in the pavement construction. So why we care about this? So we can have several advantages when we are using biobinders. For sure, the first one is the environmental benefit. So when we are using the biomaterials, we lower the carbon footprint of the final product, because normally the biomaterials are coming from the plants and trees and agriculturals. So these biomaterials are carbon sink, because the previous life of these biomaterial, they absorb carbon dioxide more than what they emit. So the carbon footprint of the product is negative. So when we are putting these materials in the biobind, in the bitumen, so we lower the total carbon footprint. We are using the renewable and waste materials, so is helping the circular economy as well. They may have some economic benefit, especially now with all of the conflict in the world and the war in Middle East. So the price of the oil is increased, the price of the bitumen is increased, but these biomaterial, their price is still steady. So it could have some economic benefit in future as well. And technical benefits. So we can manage using this product as a modifier, as I mentioned, and can be engineered to provide the broad spectrum of the technical benefits as well. Next slide. But we have some challenges as well. So we need to be careful about the aging resistance of these products. So we know that the durability is very important. So long-term durability, the most sustainable road is the more durable road. So we don't want to build a road with the low carbon initiative, but the next year we need to mill it again and rebuild it. So it's very important that the lifespan of the road will not be changed or affected in a negative way. So the future recyclability is also very important. The most recycled material in the world is asphalt. We can use 100% of the asphalt again as a new asphalt. So it's very important that when we are introducing the biomaterial in a bitumen and in our pavement, so in future we can recycle it again. Variability in composition is very important. So especially when we are using waste material, so the quality of these we have to be sure that they are consistent. Compatibility with bitumen is important. Storage stability is also very important. So all of these challenges we are facing, and when we are designing the material, we have to look at all of these. Next slide, please. And as I mentioned, so the low carbon roads, low carbon binders, when we are designing them, we need to take care about the HSE, the consistent quality, recyclability, similar life duration, emulsion and PMB compatibility, no other issues, no fume, good workability, fixed price over tender period, ability to perform with high amount of RAP. RAP is the recycled asphalt. Low emission level, no extra logistic investment, climate change impact readiness, and VAR mix technique compatible as well. And these are the targets that presented at the previous AFA conference last year in November. Next slide, please. And with considering all of these parameters and aspects, so we developed a product, we call it SAMIGreen. So SAMIGreen is the biogenic modified range of binder for asphalt and spray seal applications. It's developed in Australia 3 years ago, but built on 20 years of experience that our corporate company had in the world and as an international big corporate. And it comes with the official safety data sheet. So it's very important that we are emphasizing on the safety of the biomaterial. So we can produce it at all the conventional grade like C170, C320, which is the unmodified bitumen conforming AS 2008 spec. Elastomeric modified binder like asphalt and spray seal grades in the ATS 3110, chrome rubber modified binders, hybrid binder, which are the chrome flex version, which combining two different modifier like SBS and chrome rubbers, which also help in the chrome in the circular economy. We can foam it, we can emulsify it, and we can have a broad range of different grade in the SAMIGreen family. Next slide. And all of them are coming with the official certified EPD. EPD is an environmental product declaration. It's the official like ingredient label that your product has, and it says that, okay, how much emission does it have, how much carbon footprint does it have, what is the global warming potential, and we have the certified verified EPDs that they are all registered in EPD Australasia. Is the only bituminous product that is registered in EPD Australasia, and it is available for the public. You can go to the website EPD Australasia, search SAMIBitumen, and there are 33 different EPD for the different products there, and you can download them free of charge. Next slide, please. And these are just the carbon footprint number of one of the grades that we call it A15E. A15E is the polymer modified binder, the most well-used polymer modified binder in Australia, especially when we are going to the East Coast, Queensland, New South Wales, and also in the Western Australia. The most popular PMB is A15E. Victoria and the airport grade is more A10E, but it will be the same. The ratio will be the same. For example, with the normal A15E, the carbon footprint of 1 ton of the binder is 851 kilogram of CO2. But when we are talking about the SAMIGreen A15E, it reduced to 314 kilogram CO2 in the deep version, and in the light version is 529. So why we are developing the light version and deep version? Because of the economic and finance of the project as well. So in the deep version, we are talking about 60-70% carbon reduction of the binder. And in the light version, we are talking about 40-50% carbon reduction of the binder. But the impact, the economic impact of the light version is much lower than the deep version. Next slide, please. For example, in 1 kilometer of the road, 1 lane, if we lay the asphalt with the AC10 asphalt, 5% binder content, 5% void content, the raw material that we are putting in that asphalt with the SAMIGreen deep A15E binder, with the conventional A15E, it will be 51% less CO2 equivalent. Next slide, please. These are the properties of the binder compared to the ATS 3110, which is the Australian national standard for the PMB. You will have this slide. You can see the numbers afterward. Next slide. So this is very important. This is the aging pattern of the binder. So the graph at the top is the normal A10E binder, and the graph at the bottom is the SAMIGreen A10E. And we did several cycles of the aging on the binder with RTFO, RTFO plus PAV, RTFO plus 2 cycles of PAV, which simulate the aging of the asphalt for more than 10 years. And we saw that the aging pattern of the SAMIGreen binder is very similar to the conventional binders. Next slide, please. So side-by-side comparison of the asphalt performance, TSR, wheel track, resilient modulus, ideal city. So these are all the performance of the asphalt for moisture sensitivity, for the fatigue performance, for the permanent deformation, and for the cracking. And we saw that the different version of the SAMIGreen is very similar and in some cases higher than the normal conventional counterpart. Next slide, please. Recyclability, as I mentioned, is very important. So we age the SAMIGreen binder in the lab. We put it again in the new asphalt, and we test the recyclability of the binder. And we saw that the fatigue performance of that recycled binder with the SAMIGreen is very similar to the fatigue performance of the recycled binder with the normal PMB. Next slide, please. Delta TC is also relaxation properties after aging, so that the cracking potential of the binder. This is very important parameter, especially for the checking the durability of the binder at very low temperature. So we saw that the SAMIGreen binder compared to the normal binder, the delta TC value is also almost the same, which shows the durability of the binder and the relaxation properties of the binder would be the same with the SAMIGreen version. Next slide, please. Yeah, these are the applications in action. So during the last 3 years, 5,000 tons of carbon dioxide captured in Australia by putting SAMIGreen binder in the roads. So more than 10 successful projects in the last 3 years in Australia. As you can see, several of them was in Victoria. And current work, actually, this week we had a project, just 2 nights ago, we had a project of laying the asphalt with SAMIGreen binder in Bendigo area. And we had another one in Queensland. So it's in place and it's ongoing. Next, please. Yeah, so these are some field test results with the binders, the projects that we had actual asphalt produced. So you can see each table is for different projects. So all the result of the wheel tracking, resilient modulus, average fatigue, TSR. So all of them are very similar to what we get with the normal conventional binders. Next one. And these are the same. So especially the first table is from the project in Victoria, the first one that we did. You can see that the wheel track at 60 degrees is just 0.5 millimeter. Resilient modulus is 3000 megapascal, and average fatigue life is 1.3 million cycles, which is normally what we are seeing in the conventional binder as well. And the table at bottom is a project in Western Australia. So again, we can see the similar number, which all of them are good numbers. Next slide, please. Yeah, so at the end, the takeaway and recommendation, biobinders present a promising pathway to our sustainable payment and applied in several projects already, both in Australia and overseas. So it's very important. The selection of material, process, and binder type is very critical to performance, and we have to always ask for the safety data sheet. And one of the projects that we just did 3 weeks ago, it was a spray seal job as well. So far we had a lot of asphalt job, and recently we did one with the spray seal as well in Queensland. Next slide. And yeah, at the end, so SAMIGreen, the same technical performance, the same lifetime, same durability, with the lower carbon impact, more than 60-70% carbon reduction compared to the, depending on the grade, proven in laboratory and field, fully supported by very transparent EPD and SDS documentation, and winning some innovation award in the last few years in Australia as well. Thank you very much for your attention.
Thank you, Hamid and Brad. That was fantastic. I'll open it out to our panel. I think I might go to Nicholas for this time. I think this might be your natural territory. But Nicholas, take it away.
Thank you. Thanks, Brad, Hamid. Great presentation.
Thank you.
So with the biogenic binders, you mentioned 3 years ago you've come up with the product. That's kind of like what we understand the market in terms of the technology, really taken off in the last few years. I really appreciate the key challenges that you highlighted in the development of your product and the considerations around that. From a DTP's perspective, it's as with any new material, is really understanding, particularly with the aging resistance and durability in the long term of what it does to the binder.
Yeah.
You've had a slide around AS 2008 and ATS 3110. So
Yes.
for those in the audience, all our asphalts and the mixed designs that are registered with DTP, we all require either a unmodified bitumen from ES 2008, or 3110, which is the polymer modified one. So in terms of that SAMIGreen product, I mean, it can be adapted to any of the types and grades that fit within that suite. So what that actually means for, say, a project is, if you're using a stone mastic or a polymer modified mix, there would be an associated grade. And if it's an A10E, for example, as long as it meets the engineering properties of that ATS, then it can be used. Which really, in terms of the potential for use across all the DTP suite of mixes, there'll be a very broad application of potential for it. So hopefully that's just provide a bit of context. I've just got one question.
Just a thing that I want to add to that, the thing that you just mentioned. Actually, it's very true that one of the good point of using this kind of binder at the moment, when they are meeting the current specification, is that you don't need to change anything in your design. You don't need to redo the mix design, or you don't need to look at your pavement design. So it's just a direct replacement. And as long as these binders, they are meeting the current specification, which they are, you can just use it and actually enjoy the environmental benefit of the product.
Yep. So Hamid, just a question just around the implementation or development of this product. Like with any new technology, there's a process of getting it establishing your supply chains, sourcing your actual component of that biogenic material. So could you just maybe just give us your thoughts or your experiences on the current limitations on supply or production of the SAMIGreen?
Yeah, so for the production, there is currently no limitation. For sure, our plants, all of them are equipped for the production of the SAMIGreen. So the production process is a specific, but we implement the production process in all of our plants, and which we have in all the major cities. So the production wise is no issue. In terms of procurement, like every other raw material, so the procurement of the material is always challenging and in some cases fluctuating. But we are sure that we actually studied the biogenic feedstock that we are using, that it should be available as much as we need. And also one of the criteria, for example, that when we wanted to choose the feedstock, it was that it shouldn't compete with the food sources, because we always know that the biomaterials that they are related to the food sources is always sometimes might be challenging to get them. The price of them can be fluctuate a lot. So it's very important that we choose the material that it is bio, and also it is waste from the other industry. So we can use them as a biomaterial. So in terms of availability, I think there is no issue for now to meeting the demand of the market.
Thanks, Hamid. And just one last question. The potential for the local market, Australia is a very different country from, say, Europe and all of that. Can you just maybe help me understand what your views on the potential for getting this or establishing this within Australia is?
Yeah, at the moment, I will let Brad also to answer this question, is more on the market side. But my view is that at this stage in Australia, we don't have any incentive in terms of economic of the project, any incentive for the contractors and the suppliers to use the low carbon products. We know that currently the low carbon products or biobinders can be a bit more expensive than the conventional counterpart. But in some countries in Northern Europe, for example, there are some incentive for the contractors to use those more expensive products. But here, as much as I know, there is no kind of those strategies in place yet. And at the end, always everybody like the product, everybody like the product, the durability, the longevity, the technical performance is the same. The environmental benefit is huge, but who will carry the additional cost? So
yeah, I think Hammer, just to expand further on there. So there are no, incentives by government to have any biogenic material in. But what it does do, it gives the head contractor the ability to advertise to their customers and their investors, hey, look, we are investing in sustainable solutions. So move forward with us as the head contractor on doing these major projects, and then you'll get the benefits that we've been able to secure.
Might add quickly, the intent of the Recycle First policy is obviously to drive industry, government, and contractors that direction. But Leanne, I would like to open to you for any questions that you would have.
Yeah, thank you. I have similar questions around supply chain, so source of feedstock, and that type of thing. So you mentioned that it's waste products that you are sourcing from. Keen to understand the mix of, are these all locally available waste products, or is anything being imported in order to make the biogenic mix, sorry.
yeah, at the moment it's imported products, but we are looking on some alternatives that it will be locally available in Australia.
But only the biogenic component is imported.
Yes.
So
Yeah.
we manufacture the product locally here in Australia.
Okay, yep, understood. Yep. Is there an opportunity for you to onshore that? I know you just said you were looking at opportunities. How is that looking in terms of viability of using local waste products?
Yeah, so that it's not only the waste product, so it should be bio as well, because the bio-based product they are carbon sink and they are negative in carbon value. There are a lot of waste product that we have been used in our product, like waste plastic, waste. We are using end-of-life chrome rubbers, for example. But these products is good. They are waste product, is helping circular economy. But in terms of reducing the global warming potential and carbon footprint, they are not helping that much, because the best case, their carbon footprint is zero. And they are not zero because you have to have some recycling process as well. But with the bio-waste material, the carbon footprint of those are negative, because the previous life of those material, actually they captured a lot of carbon dioxide as a plant or tree or whatever.
Yeah, so I meant the actual bio-waste products. How are you going in terms of you're looking at sourcing them locally?
Yeah, so we have some options in Australia, some feedstock that can be useful for the biobinder. At this stage, we are looking at them in our laboratory, and yeah, so we have to check all of those constraints and things that I mentioned on that slide to be sure that that we can use them actually.
Yeah, I just think from a broader circular economy perspective, that would be obviously a fantastic step to get to. Not only are you kind of closing the loop or shortening the loop by making it based in Australia, but you're also providing additional economic opportunity within the broader value chain for the local economy, which would be great to see.
Yeah, it's definitely something that we're looking at. But as Hamid said before, we've got to be very careful with the quality of the products that we're able to secure and put in these products, because if we don't have the durability of the binder, then anything that we do is just totally offset by having to do it again sooner.
Yeah, no, I understand that. Yeah. So and my other question would just be, so at the moment, like, 'cause obviously everything's sounding quite good, and we know biobinders are a really positive step. So what are the main limitations that you're seeing, or the main challenges that you're having in terms of really taking this to scale?
I think probably the major challenge that we have is one, getting people aware of it. to getting over the perceived risk that there is a risk of using this type of product. But the more that it gets used, then the more that people will see, oh, this actually works exactly how these guys say it works. Therefore, that perceived risk, reduces.
Yep. Yeah, Joy, I don't really have anything. There was just
No
more
worries,
around the actual feedstock as well.
Yeah, thank you. And look, I think that brings us to a little over time for this presentation out of the way, but I'd like to thank Hamid and Brad for sharing that with us. If you jump into the Q&A, I think, Brad, you've answered a few questions, but there's a whole heap there more for
Yeah,
you
I'll answer
for
those ones.
Sammy. And without further delay, I now introduce James McGregor from Second Life Solar. Talk about something a little bit different, but yeah. James, I invite you to the floor.
Great, thank you. Hi, everyone. My name's James McGregor. I'm the Chief Technology Officer for Second Life Solar. And so we're, I guess, a new startup based in Victoria, and it's also have offices in New South Wales, looking to bring circular economy solutions to the solar sector. So to kick off, I want to sort of start off with a few numbers. So Australia has been probably one of the world leaders in terms of per capita adoption of rooftop solar. 1 in 3 homes in Australia now have a solar system on. If you're in Queensland, it's actually 1 in 2. But with that comes a waste problem. So if we look at the waste modelling, at the moment, Australia is set to sort of accumulate about 1 million tonnes of solar panels by 2033. So to put that in perspective, if I lay all those panels down end to end, that would go around the planet 3.3 times. Right? And that's an awful lot of solar panels. And these are only the solar panels that are installed pre-2012. All right, so we took the bulk of, we've seen massive growth in solar, so that number is going to grow very rapidly. Next slide. What's more shocking is that in the early days when we started looking at this, over half of the solar panels coming into the waste stream are fully functional. Right, there's nothing wrong with them. Now, they come off projects for a whole stack of reasons. So oftentimes it relates to building renovations, roof repairs, those sorts of things. But also we're also seeing things like the inverters, which is the power electronics that converts the DC voltage from a solar panel into an AC load, so you can connect to the grid. Those inverters last 10 to 12 years. So what's happening is solar panels become so commoditized, a bit like your mobile phone. When the inverter dies, people take the opportunity to update to a new, shinier, newer system, even though the actual solar panels themselves are perfectly fine. And solar panels are actually designed to last for 25 or 30 years. And so when we first started to encounter this problem, actually it was with the New South Wales Government, the Department of Education. We were working with them. They had rolled out solar panels on thousands of schools across New South Wales. And then about 5 or 6 years later, the asset management team came along and realised that a lot of those buildings are very old and the roofs need to be replaced. So they took the systems down, put new roofs on, and then realised actually it was cheaper to throw them away back then than it was to actually put them back on the buildings. And they thought that can't be right. And so we worked with them to sort of come up with a solution. And so because we're circular economy practitioners, most of the discussion around solar panel waste focuses on recycling. But as we all know, there is a hierarchy of interventions you can do. And so we went up the hierarchy towards the top of the list. So things like Rethink, we're designing systems specifically for end-of-life management. But in particular, we focused in on the reuse element of solar panels. So if we go to the next slide. And so one of the reasons we focused in on reuse is that we looked at all the unit economics of the different particular applications you could do for a circular economy approach. So in terms of recycling of solar panels, they're quite difficult to recycle, right? So give you an idea of the composition of a solar panel. So you have an aluminium frame around the outside. That's relatively easy to get off and recycle. But then you've got a layer of glass, which is glued to a layer of EVA, which is then glued to a layer of silicon, which is then glued to another layer of EVA. And then you've basically got a fluoride backing sheet, which keeps the whole thing watertight. So all that stuff stuck together. So actually pulling a solar panel apart is actually really, really difficult. So in terms of recycling, so whilst there's maybe $15 to $20 worth of materials in that solar panel that could be recovered, the cost to process it is, big bits of equipment. It's quite expensive in terms of the capital. So what you're left with is a residual value if you recover everything, which actually in 2026 is not possible. Things like silver are very difficult to recover. The panel's worth about $2 to $3 of residual value, economic value. You can sell the things secondhand. You jump on Facebook Marketplace, people are buying and selling them for camping and caravanning. Pretty niche market. It's not going to absorb the millions of solar panels that we've got coming into the waste stream, but you can sell them secondhand, and you get 35 to 40 bucks for a panel like this. There was an active international export market to places like Africa, but there's some ethical concerns around that. But then if we look at reuse, the great thing about solar is that the most valuable thing a solar panel produces is a kilowatt hour of electricity. And so, and the nice thing about solar is there's no moving parts. You stick it up on top of a facility, it just chugs away there quietly, no pollution, producing electricity year after year after year. So this 8-year-old solar panel designed to last for 25 or 30 years. In year one would produce about $117 of electricity. By year 5, it's produced $585, and by year 10, it's produced $1,170. So just on the pure value, like what circular economy intervention generates the most value that you can capture, reuse is way orders of magnitude at the top of the list. Next slide, please. And so as part of that work, the first question that comes up is, well, actually, how many panels are suitable for reuse? And how do you know if the solar panels are actually any good for reuse? And so we worked with the CSIRO, the energy division up here in Newcastle, and we developed basically a mobile testing rig. So one of the challenges with solar panels is we're a very big country, and solar panels are spread over a very large geographic area. And so moving panels to a big centralized location is uneconomic. So we designed a mobile rig so we could go out and test panels in situ. And what the test rig does is it does 2 main tests. So we measure the power output. So we basically shine light on the solar panel inside that box there, and that produces a power curve. So now we know electrically is the panel putting out the amount of power that we expect. And typically a solar panel will degrade at about 0.5% per annum. So a 10-year-old panel, you still expect to put between 90 and 95% of its peak output. But then importantly, what that doesn't tell you is the mechanical condition of the panel. So the other test that this rig does is something called an electroluminescence image. And basically what we do is we run the panel backwards. So we basically put power into the panel. And so instead of absorbing light, it actually produces light, a bit like the LED light at home, although it's extremely inefficient at doing that. So it's not designed to do that, but it produces a specific wavelength of light. We can use a very special camera, and you can see the 2 images on the screen there. The one's a good panel, and one's a bad panel. And what that tells us is what's going on inside the solar panel. So the one on the left there is beautiful monocrystalline silicon solar panel. You can see very few blemishes on it. Basically, light colors are good, dark colors are bad. You can even see the individual circuits on there, so we can pick up things like micro cracks. And importantly, what we can see is something called photo-induced degradation. So that panel on the right there, which is in pretty poor condition, is suffering what's called photo-induced degradation, which is generally breakdowns of the polymer layers around the cells, which creates effectively shading, which then significantly affects the performance of those particular solar panels. So, and there's also a few cracks, actually, at the top left-hand corner there, you can see a couple of cracks there in those cells. So with those 2 tests, we can put hand on heart and be pretty confident to know if that panel is suitable for reuse. Next slide, please. So what we did is we then went out into the field. So remember, we thought 50% of the panels would be suitable for reuse from our early work and some waste audits that we did. The first time we deployed this test rig in anger was down in Wagga Wagga in South Wales. You can see the picture there of me with those panels in the background. There's probably a couple of thousand panels. We spent a couple of days testing, and 89% of the solar panels at that waste facility that was sent for disposal were perfectly good. The ones on the left there usually had things to do with junction boxes, pretty minor things. Most of it was actually is repairable, although the economics of repair is questionable, but 89%. Next slide, please. Last year, we did a very large project with Queensland Government and the Smart Energy Council. And we tested 5,067 solar panels, and I know that number because I lifted every single one of those myself at 22 kilos a piece. That's 110 tons of solar panels moved by hand. So not only do we do solar panel testing, you get a free shoulder workout at the same time. And so of that one, that was part of a big project. This is the biggest data set in the world, looking at what actually is going on in solar panel waste streams. and we had a 55% pass rate of that data set of those panels up there. And so, and those panels were in pretty poor condition, like they'd been sitting in council facility for years, full of dirt, geckos, spiders, all sorts of stuff. But nevertheless, over half of those panels were in perfectly good condition. Right? And actually, the oldest working panel we have, which I actually have down in my garage, was a 26-year-old BP solar panel that's still putting out 94% of its peak output. It's 26 years old. So next slide, please. So that was in Queensland. Here's some of the data from that testing. It comes up in a minute.
Apologies, having a couple of technical issues.
That's all right.
Sorry, James.
I'll mime the graphs. So when the slide does come
Sorry.
up, what you're going to see is, so in that testing in Queensland, so we tested over 100 different brands of solar panels, and they range from 160 watts up to 370 watts. And the ages from like 2008 to 2021 sort of age range. So what we found was, so while solar panels are designed to last for 25 or 30 years, with this data set, what we found actually validated what we've been seeing elsewhere. It was that the average age of those panels, of those 5,000 panels, was just 12 years old. All right, remember, a solar panel is designed to last for 25 or 30 years. And that's pretty consistent with what we're seeing across the market. And if you look at the chart there on the top right-hand side, that the panels that are the best candidates for reuse are ones that are probably around that 10 years old mark. And those panels, because you get at least another 15 years worth of service life out of them. If you look at the pass rate for those particular panels, you can see for panels that are younger than 10 years old, the pass rate was well above 80% pass rate. So what that means is there is we have more panels than we have projects coming into the system, and they're all suitable for reuse. Next slide, please. So I'll get bonus points for my miming of the graph there. So hopefully everyone got the gist. And just for Christmas again, there's another data point. We're working with Upper Hunter Shire Council to basically test and redeploy panels in their shire. And so we just before Christmas were up there testing shipping containers worth of panels, which was 387 panels. 84% of those panels that we tested were perfectly good for reuse, and they're actually now being redeployed onto things like sewage treatment plants, wastewater pumping stations, the local sale yards. For those who know Scone quite well, quite a big agricultural sector with cattle and famous for racehorses. So they've got sale yards and stuff up there. So next slide, please. So what does all that mean? So, at the moment, we estimated about 50% of the panels would be suitable for reuse. Our field testing suggests that it's much, much higher than that. So it's probably in actual that 60 to 70% range. But let's just, for argument's sake, to make the maths easy, if we say half of the panels that are currently coming into the waste stream in Australia are suitable for reuse, that's the equivalent of 8.1 gigawatts worth of perfectly good solar panels that Australians are throwing away, or 27 million panels. And 8.1 gigawatts, if you're not into energy in the solar space, that's the equivalent of all of the solar panels installed across the entire country over the last 2 years. That's a huge, huge number. And that's just where we are today. That's as we go forward, that number is going to get bigger and bigger. As we get up to 2040, 2045, if the same trend continues, we're talking like 45 gigawatts worth of perfectly good solar panels ending up in our waste streams. Next slide. Of course, we all sort of touched on the unit economics of this. So if we convert the value just to 2035 of that 8.1 gigawatts, that's $38 billion worth of electricity those panels can produce to the economy. So, at the moment, Australia is trying to grow its renewable energy base. We're importing millions and millions of panels every year, but at the same time, we're throwing away a whole stack of perfectly good panels. So it's like trying to fill up a bucket with a hole in the bottom of it, right? So we need to actually look at kind of redeploying these panels into local projects. Next slide, please. So question then becomes is where can you deploy these particular solar panels? So we're working on a range of different projects. So Lily, if you just press forward one more time so that video on the bottom left hand starts to play. So there's a range of applications. So we have some mobile technology that's particularly suitable for road construction works, where you've got temporary infrastructure requirements. So these are shipping containerized solar systems that are designed specifically for reuse. Things like roadside signs. If you're obviously working, I know there's a lot of people in roads and infrastructure here. Every day when you go to work, you're probably going past thousands of solar panels, from speed signs to temporary lighting to safety signage to on the site sheds, and all of those installations are generally temporary or short-term installations. So you can see the mobile unit being deployed there. We have rooftop systems, so we deployed numerous rooftop systems, and there's also tackling energy poverty. So we are working with some charities in the South Pacific to look at setting up microgrids using reused solar panels as well. Next slide, please. So this is the project we did late 2024. So this is Australia's largest demo of a reuse system. So it's 102 kilowatts down at a recycling facility in Wagga Wagga. And you can actually see in the photograph there slight different coloration. So there's 7 different manufacturer panels on that particular system. And the reason we did it actually as 102 kilowatts was that if you're familiar with the renewable energy certificate scheme, there are things called LGC, so large scale renewable energy certificates, which you can claim for systems over 100 kilowatts. So we built this at 102 so that we could actually test the legislation around whether we could claim LGCs for reused systems. And the short answer is yes, we can. It's fully compliant with Australian standards. And so, yeah, that's the biggest one in Australia. And not wanting to brag, but we've also won a swag of awards. Most recently, the Smart Energy Council's inaugural Excellence in Stewardship Award last year, but also picked up awards from World Wildlife Fund, New South Wales Government, and the Banksia Foundation. Next slide, please. So recently, we've also been doing quite a lot of work with council. I think this picture actually sort of shows that economic value of reuse versus recycling. Now, I should say recycling is really important, right? There are lots of panels that have to go for recycling. We can't do without it, but there are big opportunities in the reuse space. So these are the panels from actually Upper Hunter Shire Council that we tested just before Christmas. So these are all the panels that actually passed. But there's 25 solar panels on each one of those pallets, about 500 kilograms worth of solar panels. If we were to send one of those pallets off for recycling, it would cost the council about $250 plus whatever it costs to transport, because they're in the Upper Hunter. They'd have to send them to Sydney. So that probably realistically more like $500 for that pallet for recycling. And you can see there, these panels are only 6 years old. They actually came off a local RSL that was having an additional floor added to the building. So their old system had to come down. And so they're quite young. So they've got a good 20 years remaining in them. And so that one pallet there can produce about $50,000 worth of electricity for the council. And so we're now redeploying those onto various facilities in that council area. Next slide, please. All right, so a little bit about what we do. So we're a startup, been going for about 3 or 4 years now, although we've been working on this problem a lot longer than that. So we offer a range of consulting services. So if you are a solar asset owner and you're wanting to put some circular economy strategies in place for those solar assets, we do circularity assessments to the new ISO 59020 standard on circular economy. Obviously, solar panel testing and reuse projects, so everything from decommissioning to then redeployment. And we also do new systems that are designed with circularity in mind, so designing for end-of-life planning from day one. And reuse projects, we've got the mobile energy and battery solutions, particularly good for temporary power for construction sites, mine sites. To give you an idea, side-by-side comparison. So if you have 100 kVA genset running on your diesel genset running on your construction site, one of these units can save you about $70,000 worth of diesel per year, as well as about 170 tonnes of carbon emissions, and basically giving you the same product, which is electrons. We're also doing some pretty interesting projects around using those mobile units for emergency systems and natural disasters. For example, Upper Hunter Shire Council, as well as down in Victoria on a golf course, where when those mobile units aren't required, they basically sit on a facility and produce renewable energy and run, in our case, up here in the Upper Hunter, a sewage treatment plant. But if there is a bushfire, they can be packed up in about 45 minutes, transported into a community oval, run a community facility, deployed in about 3 hours, and you've basically got a standalone mini grid with a battery integrated, so you don't have to worry about carting, say it's a bushfire, diesel fuel through a bushfire area. You can run mobile command centers, all sorts of quite interesting applications there. So if you're an agency that's responsible for providing emergency power in natural disaster situations, it's a good economic way, because while the asset's sitting there, it's generating power, and you can basically pay for the asset while it's not in use, so it's not sitting in a warehouse waiting to be deployed. And then, of course, end-of-life solar asset management. So decommissioning of systems. So we'll come and take systems down, give a clean roof, and get those off to recycling. We don't do the recycling ourselves. We work with a range of recycling partners around Australia, and we do all the reverse logistics, which is actually one of the harder bits of solar panel collection and recycling. And in particular for councils and installers, we also provide a solar panel waste management service. Next slide, please. And so given I've got a captive audience, I thought I'd put an ask out there. So at the moment, of course, if you've got projects around solar panel reuse, you're interested in the mobile units, we'd love to talk to you. In particular, one of the hardest challenges around managing this waste stream is because solar panels are so geographically distributed around the country and recycling facilities are so centralized, getting panels from where they are to a recycling facility is very expensive and very difficult and very hard to do. And so what we're doing is we're setting up a milk run model with councils. So we're looking for council partners who want to establish drop-off points. We've got stillages that maximize the amount of panels you have per truck. We want to get full truckloads, so that reduces the cost per panel. So yeah, really keen to talk to councils, and also redeployment into local projects for those councils interested in reuse. Pretty easy process. So the first step is we do a model the PV waste for your local government area, and we have very good data down to postcode level. So we can give you projections out to the sort of next 5 or 10 years on what to expect in your council area. We'll set up some stillages for basically storing the panels, and also allows for efficient transport, get as many panels on a truck as possible. And then for those who are interested in solar panel reuse, within third stage is generally setting up the reuse projects and deploying those good panels into community projects. Next slide, please, which I think is my last one. Yep. All right, so just to wrap up, so yeah, being pretty conservative and saying if half the panels coming into the waste stream are suitable for reuse, Australia could be throwing away 8.1 gigawatts worth of perfectly good renewable energy generation capacity. So that grows to about 34 gigawatts by the time we get at 2045. By taking this proper circular economy approach, which is not just recycling, there's lots of ways organisations can unlock value from their existing solar panel assets. Thank you.
Thank you, James. Look, for certainly for me, and probably for some of the people in the audience, we probably didn't understand the scale of this issue. So I think you've certainly highlighted something to us. I'm going to open to the panel, see if anyone has questions first. Leanne.
Yeah, I'm happy to jump in. Yeah, James, thanks for sharing that. This is fantastic. It's really great to see the holistic kind of nature of what you're thinking, and obviously to see higher order reuse actually kind of being intentional, and also seeing the economic kind of value of that, because I think often we look at recycling, just that's what we do in Australia, as kind of the economic value, rather than reuse being a significant economic value, both in saving avoided costs, but also as in creation of value creation. I have a lot of questions. I won't ask them all because I think there's quite a lot to this. The first one, I guess, is just a pretty standard one, which is like if solar panels are designed for 20 to 30 year design life, and they're being recycled at 6 to 10 to 12 years, why is that? And obviously the reuse market. So even before we get to the reuse market, extending the life of existing assets has to be a important step. So interested to understand why is that happening, and what can we do to basically help re-educate or recondition, or like the maintenance aspect to actually help extend the life. Because I was surprised at both how much capacity is still left in the panels that are being discarded, but also the age of the panels that are being discarded.
Yeah, and we were too when we started looking at this problem. I mean, I designed a bit of history, so I designed my very first solar system in 1994. And as a young, graduate engineer back then, I was like, I don't have to worry about end of life of these solar panels. That's like 30 years into the future.
Yeah.
Here we are 33 years later, and we're now trying to tackle this problem, right? So I think people are like, people who worked in the sector and were designing just assumed like this, because I remember that solar panels were designed for space applications originally. So they were designed to be out in space where you can't get to them. So they were designed to last for a very, very long time. Anecdotally, a lot of the drivers around early retirement. So I think building construction works are a major one. So where someone does a repair to a roof or building modifications, we see a lot of that where the panels are quite young, but there's some construction works going on. The panels are on the way; they got to take them off. They just want to the builders don't want to deal with that; just want to get rid of them and get on with building the structure. We're also seeing, I guess, a lot of systems coming in where the inverters, so there's two parts of solar system. So there's the panels that produce the DC voltage, but then you'll have a box near your switchboard, which converts the DC into an AC current, put an inverter. So it's basically full of power electronics. They typically only last 10 to 12 years. So I think what's happening a lot as well is when the inverter fails, people just think the whole system's dead. And then they ring up an installer, say, hey, new system, there's no economic incentive for the installer to repair it because they make their money from installing systems, so they just pull the whole system off, right?
Yeah.
And then the other driver, that's a major driver, and this is a bit of a market failure from the Clean Energy Regulator, is that the small scale renewable, you get when you do a system under 100 kilowatts, you get what's called an STC, which is a small scale renewable energy or small scale technology certificate. And so it's basically like a rebate on your system. The legislation specifically prohibits getting a rebate for system repair. So if you replace a panel, you can't get a rebate for it. So it actually, the economics incentivizes you to throw the system away and put a new one in because of the value of that rebate. Now the renewable energy target comes to an end in 2030. So those rebates will no longer exist. So I think in 2030, that landscape would change dramatically. But then people will start looking, it makes more sense to do repairs. Because oftentimes when we've got batches, because we've tested 7,000 or 8,000 panels now, and they come through in batches, right? So you'll get a whole lot from the same building. And oftentimes we'll test them and there might only be one or two panels that have failed in the whole system, but that actually has, because they're all connected in series, that has this detrimental effect on the whole system performance. So I think repair will become more prevalent post 2030, whilst this economic incentive that sort of disincentivizes repair is in place.
Yeah, it almost sounds to me like that solar panels could be kind of like how we are with cars. Like, cars have a design life. There's a very healthy secondary and tertiary market for cars. If they're well conditioned and well looked after, we obviously have repair, we have maintenance. This is a similar potentially type of, market that we could be looking at, which to help extend that life.
And particularly if you're, so one of the areas we're starting to focus on is that if you've got a system that's 10, 15 years old and you need one replacement panel, well, where do you get it? Because no one's making them anymore. So collectively within the system, you'll be able to find and identify those panels and then redeploy them for repair work. So when our test rig, we basically scan the barcode for every panel that goes to have an individual test report. That also extracts all the panel information as to what model is it, what's its wattage, what's its electrical performance. So now we have a database. So if someone rings up and wants a Longy Solar 263P1, we'll look it up. There's one at Bankstown. All right, we'll get it. Amazon will pick it up and we'll deliver it tomorrow. That's the dream.
Fantastic. That sounds fantastic. Last question from me. I do have lots more, but what is some of the things that government, so you've obviously talked a lot about what you're doing from a market perspective, which is fantastic, and really kind of taking the leadership and control of it. But what are the things that maybe government could be considering to enable greater reuse? One thing that I thought of in terms of infrastructure projects, we often specify the use of solar panels for temporary works or we don't specify the use of reused solar panels. So, that's one thing we could potentially have control over from a government, infrastructure perspective. So just interested to hear your thoughts of what are the major things that government could be considering to really support this kind of opening up of the secondary market.
Yeah, so I think Victoria's great because you guys are the only jurisdiction that have actually banned solar panels from landfill. So I think the other jurisdictions need to ban solar panels from landfill for starters. because that's where a lot of them are going outside of Victoria. I think, yeah, to your point on the specifications, I don't think you even need to go to the point of actually saying specifically reuse. I think if we've got now an international standard on circular economy, so the ISO 59020. I think if you just like nominated a specific circularity target, like percentage, and you basically get a percentage score in that, then that would then drive reuse and or recycling. So it'll force manufacturers to start using recycled content, which they currently don't really do, many of them. But then also then creates a bit of a level playing field for reuse projects. I mean, the economics of reuse stack up pretty well, and particularly if you're doing construction sites where your site facilities are only there for 5 years. Things like roadside signs, typically they've got a 5-year service life typically, and it's not because the rest of the trailer and stuff is failed. It's because the electronics that talk to the sign get out of date and the software's out of date, so you got to replace. And so a lot of the rental companies just basically write those off after 4 or 5 years. So I think, in terms of specifications, there's one, including some sort of circularity score, not a recycled content, not a reused content, but a circularity score, because that then opens up the playing field for everyone. But then also being end customers. So a lot of our customers are government, particularly in New South Wales. So we are working with, can't say who they are, but it's one of they might do roads and stuff like that. So on vehicle depots and all those sorts of things, because they have circular economy targets, a bit like in Victoria. And it's an easy win for, if you've got circular economy KPIs on a project and you're putting on solar anyway, it's like a super easy win to use a reuse panel, because then you're basically hitting renewable energy, net zero, and circular economy target all on a project you're going to spend money on regardless. So you don't even have to spend any more money.
James, I will get Nicholas to ask his questions. In the interest of time, I do want to give our last presenter, the full opportunity as well. Nicholas, any questions perhaps last questions for James?
No questions from me. I think Leanne's asked and covered that very well. And I also appreciate, the information and insights you've given, James. It's been very, very helpful. Just a comment, just saying it's really good to see this reuse focus, and looks like you've got a very bright future ahead in terms of the amount of used solar panels and needing to find a second life in the future.
Yeah, we've got to definitely have an endless supply of panels to find new homes for, that's for sure.
Thank you.
Thank you, Nicholas. Thank you, James. And again, the call out, councils, projects, anyone in the audience, James' contact details will be made available after this. So without further delay, I now hand over to the team at Armstrong Flooring for something a little bit different and something very exciting, an Australian first. Michael, Samantha, please take it away.
Thanks. Armstrong Flooring has been a part of Victoria's manufacturing landscape for over 50 years. With production beginning at our Braeside facility back in 1969. Today, we're proudly Australian owned and remain the country's only manufacturer of commercial sheet vinyl, which supports hospitals, schools, and major projects across Victoria. Our focus now is on the next generation of manufacturing, advancing circular product innovation while continuing to support Victoria's infrastructure sector. Today we'll introduce our team and share a short manufacturing video and highlight some key projects, and then focus on Innover and Floor Cycle, which are coming in, before outlining opportunities for pilot partnerships as well. We'll skip to the next slide if we can.
Next one.
Probably the next one after that, thanks. Sorry. Today I'm presenting on behalf of our Victorian ecologiQ team, and we're bringing together expertise across product development, sustainability, specification, and major project delivery. I'm Daniel Lyon, the product manager and lead product strategy and new flooring solutions. Andrea Rose partners with architects and designers across commercial and government projects. Michael here delivers flooring solutions across major developments in Victoria and Tasmania, and Samantha Surfield leads our circularity and product stewardship initiatives, including Innover and Floor Cycle. Together we're focused on delivering practical and locally made circular solutions. Skip to the next slide. We've been manufacturing at Braeside for over 50 years, supporting the Victoria's built environment. Today, that legacy comes with responsibility to reduce reliance on virgin materials and take greater ownership of full product life cycle. This aligns pretty strongly with Victoria's circular economy transition, including ecologic and recycle first policy. It's also important to acknowledge that circular thinking is not new. First Nations peoples have cared for the land and resources for tens of thousands of years, and we acknowledge the traditional owners of the land on which we operate and pay our respects to the elders past and present. Our role is to apply that thinking to modern manufacturing, keeping materials in use for longer. If we can skip to the next slide, which is actually a video of our history and how we operate.
Lily's just going to play that.
Welcome to Armstrong Flooring. We have been manufacturing commercial vinyl sheet flooring and flooring accessories here in Australia since 1969. There are a lot of elements around flooring that people don't realise, especially when they walk into a public building. Slip resistance, cleanability, how the colour works with the rest of the building. These are things you don't see. You walk around on them every day, but the flooring element of a commercial building in particular is extremely important. By being a local manufacturer, there is a knock-on effect. When you support local manufacturing, you're not just supporting the first central business, you're supporting all the other businesses around it. From suppliers to installers, service technicians, delivery drivers and more. There's aligning businesses that spend 60 to 80% of their time working with us here at Armstrong Flooring. So by supporting us, you're supporting a wider economy. Our local manufacturing facilities and our local design capabilities allow us to respond quickly to deliver a high-quality product both locally and to export markets. Architects, specifiers and builders trust in our ability to deliver quality products within critical construction timelines. But it's not just about quality, it's about safety, and it's also about how we treat our employees. All of those three elements are held in high regard out of Australian manufacturing. Our product is an eminently recyclable one. By keeping our manufacturing local, when there's unused material from the installation process that would normally be treated as waste, we have that material returned to our plant. We granulate it and repurpose it to be reused into new flooring, allowing us to maintain a circular economy as long as possible. We endeavour to source the majority of our raw materials from within Australia. Armstrong Flooring recycles over 20 tonnes of recycled PVC every year. This allows us to repurpose materials destined to waste and landfill directly into our product. In addition to recycled materials, we also source as much new material as possible locally, including our limestone from local quarries, to ensure that our products are as sustainable and economical as possible. Armstrong is proud to be licensed to use the Australian-made logo because it reflects our goal of producing the highest quality commercial flooring possible. There's a lot of pride from our customers, the architects and designers. Even the building end users have a sense of pride around knowing there's Australian-made products in it and are very secure knowing the plant is nearby and there's full support for them going forward. Our customers choose Australian-made products and they choose Armstrong Flooring, not only because they are proud to play a part in supporting locally made products, but they also recognise that Australian-made products are known for their high quality, safety standards and reliability.
Thank you. Next slide, please. One example of our work supporting Victoria's big builders, the Frankston Hospital redevelopment, which has just been completed, which was delivered by Vita Health. For this project, we supplied around 110,000 square metres of locally manufactured product, which was produced here at our Braeside facility. Being located just 21 kilometres from the project site provided advantages including reduced transport emissions, reliability on supply and shorter lead times. Projects like this highlight the value of local manufacturing supporting major Victorian infrastructure projects. Next slide, please.
The new Footscray Hospital is another example of a project delivered under the Vita Health. Alongside supplying locally manufactured flooring, this project highlights our involvement in the hospital's PVC recycling program with Baxter Healthcare and the Vinyl Council of Australia. Recycled PVC from hospital masks and tubing is incorporated into new flooring, ensuring every square metre contains recovered healthcare materials and supports circular manufacturing.
Next slide, please. The Royal Children's Hospital expansion. We also supported this project where design and functionality come together. A key feature was our co-fillet, which created seamless floor-to-wall finishes and is critical for hygiene. Importantly, it's made from 85% post-consumer recycled PVC sourced from cabling waste, and which is reprocessed at our Braeside facility as well, demonstrating circular manufacturing in practice. Next slide, please.
Armstrong Flooring also supports Victoria's university sector, supplying flooring for high-performance education and research environments. One recent example is Monash University's revitalisation of 343 Royal Parade. Our flooring helped deliver durable, hygienic and easy to maintain environments suited to laboratories, teaching spaces and research facilities. Next slide, please.
Over the past 5 years, Armstrong Flooring has supplied flooring for more than 200 schools across Victoria through the VSBA projects. Our locally manufactured products support high traffic learning environments with floor score certifications, which promotes healthy indoor air quality for students and teachers to enjoy for years to come.
Next slide, please. Our flooring is also widely used across Victoria's emergency and safety infrastructure. Recent projects include Bentley East Ambulance Station, Barwon Prison Infill expansion, Ararat Prison and CFA stations at Winnenvale, Moe and Newborough, supporting new facilities that serve and protect the community. Next slide, please.
We partner with Australia's modular building manufacturers, supplying flooring for staff amenities across offices, kitchens, washrooms and storage areas. These systems are widely used in Victoria's big build, indirectly supported the delivery of major infrastructure projects across the state, such as government cost programs for kinders.
Victorian funded certifications. Armstrong Flooring invests in independent certifications working with recognised bodies including GECA, Global Green Tag and SCS to deliver verified outcomes such as EPDs, Best Practice PVC, Recycled Content Verification and Floor Score certification. Importantly, the development of ANOVA has been supported by the Victorian Government through Sustainability Victoria's Market Acceleration Program, enabling its recycled content verification and certification to come to market. Next slide. Floor cycle take back. To support the development of ANOVA, we also needed to solve another problem: how to recover valuable flooring material from project sites and return it into manufacturing. This led to Floor Cycle, Armstrong Flooring's Take Back program, designed to collect clean installation offcuts and return them nationally to our Braeside operations. Installers place clean sheet vinyl into dedicated bins on site, which are then transported back, weighed, sorted, granulated and reprocessed into feedstock for ANOVA. Floor Cycle builds on our existing national returns program, but uniquely captures installation waste that would otherwise be lost, returning it to its intended use as new flooring. While end-of-life recovery remains a broader industry challenge worldwide, we are working with research and industry partners to explore future solutions. Together, ANOVA and Floor Cycle demonstrate how collaboration across the supply chain can help keep materials in circulation and support a more circular built environment. Next slide. So help us pilot more circular flooring solutions. As we move forward with ANOVA and Floor Cycle to bring it to market in June, We're now looking for early adapter project partners interested in piloting these initiatives in Victoria. These pilot projects will demonstrate how circular manufacturing can work in real projects by collecting installation waste, remanufacturing it, and returning it into new flooring products. Next slide.
The development of the Innova and Floor Cycle Take-Back program represents the next step in our circular manufacturing journey. We're now looking to further partner with government, industry, and the design community to deliver the first true circular projects in Victoria. Together, we can turn waste into resource and demonstrate what circular construction looks like in practice. The question is, who wants to be a part of it? Appreciate your time.
Thanks.
Thank you.
Thank you, team. And I think, yeah, it's great to see that, you know, in terms of that circularity thought, that launching that recovery scheme is so important. And I do reiterate to the audience again, we're looking for pilots to partner with us on this. But before we get to that, I will hand over to the panel for any questions. Perhaps Leanne?
I do, yeah. First, I would, yeah, a bit of a shout out to Armstrong. You're a bit of you're unique in the sector actually, and it's kind of fantastic to see. We know that a lot of the built environment is import products. It's very rare to have Australian-made, Australian-owned products in the market, and also to have such strong circular kind of credentials. So fantastic. I have one clarification and then one question, then I'll hand over to Nicholas. Otherwise, I'll take the whole time. When you said with your floor cycle, sorry, I missed it. So you talked a lot about offcuts earlier. Your floor cycle program is a full take back, so end of life recovery of vinyl, not just offcut, sorry, recovery of vinyl. Just wanted to clarify that if I could.
I can answer that. So at this stage, our first round in Australia is installation offcuts that represent about 5% of delivered product into projects. The challenging thing about PVC, and it was quite unique when I heard the same story through SAMIBitumen, you know, the most durable products are the ones that are the most sustainable. Well, our flooring is down for often, you know, 20 to 30 years of life. And unfortunately, globally, we're searching for end-of-life solutions. They don't actually exist. We are also looking at, you know, that investment so that we can have that producer responsibility piece and that full end-of-life cycle solutions. We believe they're about, you know, 2 to 3 years out. And one day that's where we want to be looking at is to get this off the ground. Initially, we have to look at what we can do now, and then longer term, how we can get more stock feed, because we are essentially capped at our production levels.
No, that's fantastic. Yeah, I just wanted to understand that better. I mean, starting with even just the offcuts from the installation is a great place to start, and bringing that back into the loop. My kind of general question is around, so this obviously makes good economic sense for you. You've built your business around kind of circularity and some core circularity principles. Did you intend to do that? I'm interested, like what came first here for you in terms of chicken or egg? Was it the fact that these kind of decisions just made good economic sense in terms of sourcing or production or manufacture? Or was it an intentional sustainability kind of thinking strategy that led to you, I guess, establishing Armstrong in this way?
Do you want me to answer that, guys?
Yeah.
Can do.
Yep.
So 2 years ago, we had a change of ownership, and our owners are family-based, the McKendrick family, and they've owned other flooring companies. So they're very big on sustainability, and that was something that was a big step as soon as they came into the business. However, we're already reworking about 325 to 600 tonnes of our own waste per annum, but they wanted to do more. And so it was a directive from the owner down to our production manager, George, to say, what can we do more and how can we reduce our waste? And we were already bringing back crates and pallets, as we had mentioned. But, you know, there's some things with that in terms of the carbon journey as well. So, you know, and we do want to look at that end-of-life piece. It's something that they want to be responsible for. And so really it came with that change of ownership in 2022, coming from an American ownership to an Australian, and a commitment from the people who own the business.
Fantastic. Thank you. I'll hand over to Nicholas.
Thank you. Great presentation. There was a comment, or you made a comment, Sam, I think around the limited supply stock, kind of constraining how much of this ANOVA you can produce, because that's obviously at 99%. I guess that you're not alone in that challenge, where for example, with reclaim asphalt pavement, we always try and get, there may be, I guess, projects are encouraged to try and use as much as you can. But in terms of the bigger picture, having a little bit across everything kind of leads to the same outcomes, but also provides that, control in terms of potential variabilities if you go too high with a recycled product. Now, with your ANOVA product, I just wanted to understand, how is your recycled, product feed that you receive? What processes are involved with turning that waste into that product?
So, Nicholas, we've got a supply that we keep constantly. We've got what we call miscellaneous waste back in our factory, and we do slowly feed that into our Australian-made product. But also, we always keep that capped around 400 tonnes of supply. From the post-consumer, so that's our pre-consumer, which is that 49%. 1% is the coating, and then 50% is what we're going to get back across the fence from our customers. And that comes from two sources. Some is construction, installation offcuts, and others are product returns. When our flooring comes back to our facility, it's just regranulated, and we're able to drop that into our chip line. And it just goes through our standard manufacturing process.
Okay, so there's no additives or any other materials involved?
It's purely just granulated up, which then gets essentially mixed back into the pelletized raw material that then gets turned into the sheet vinyl. So it just becomes becomes a component, which I guess is part of the constraints, I guess, around uplifted materials. Is obviously got to turn that back into clean PVC without adhesives and screeds and all that sort of stuff into it, which is what the R&D is trying to work out at the moment.
And then, Nicholas, the only thing that is a constraint for us is, if anybody's worked with making a recycled product, is just those colour pathways. What we make today on our production line and what our clients, architects and designers choose as a colour, when we take that back is what's going to be a colour pathway for when we make ANOVA. So, and our batches are single runs at 600 metres only.
All right. Thank you. That's all from me. Thanks.
Thanks, Nicholas. And just to be fair to our presenters at Armstrong, we do have one question in the audience, and I think it's probably on a similar vein. I'll just ask it live and feel free to answer. So this question's from Erwin. Various sorts of contaminations are a major circular economy issue. Are you working on the strong glue stuff for the old vinyl installs, or are you able to take that back in future?
I think Michael just touched on that. That's an R&D piece. But obviously, when we lay our flooring, we've got like the concrete at the bottom, we've got the leveler, we've got the glues, and we work with specific recommended glue companies that are also looking at what are the glues of the future. However, that's part of a longer term piece, so that it would be separated in the future, and we would be able to get our flooring back in a capacity that we can run it straight into ANOVA.
Yeah, we've essentially got a number of companies around the world that are looking into, I guess, processes and things that can be done to try and remove the adhesive and the screeds and things from it. But I mean, I guess the problem faced is that when the product's put down, because it is designed to be down for 20 to 30 years, nothing is designed essentially to be easily removed. I guess probably the point of the product. So it's you're sort of designing the glues to keep it down for forever and a day, and then you're trying to work out a process to get rid of it as well. So it's obviously a big challenge, but no one's immune to it. I guess all the other manufacturers around the world, all the European manufacturers, they're in the same boat. They're trying to work out the same thing. So there's a number of different companies working on it, but yeah, we're trying to obviously do it here with the local plant.
Fantastic, thank you. Yes, one day I'd love to showcase circular adhesives here on our showcase and see where that's going to. We are at time, so for anyone who's still remaining in the audience, please join me in thanking our three presenters and panelists here today. our the copies of today's presentations will be sent out to everyone who's registered for the event, and a copy of this video will also be posted out ecologiQ YouTube. Again, as much as we love platforming these innovations, it is a call to action, a call to arms. So if you're out there in the audience, you're working on any projects that might be using Armstrong offcuts, or you're looking at repurposing solar panels or installing some new ones, or if you're laying a brand new road, please consider getting in touch with our three presenters here today, because it is a circular economy, and we can only have an economy if it's a thriving marketplace, and we're making progress on this front. So thank you again for joining today's showcase, and we look forward to seeing you at the next one. Thank you, everyone.
Thank you, everyone.
Thanks, everyone.
Bye.